Good morning, everyone. Good morning, guys. How are you all? Just tell me in the chat section. Am I audible? Are you guys able to hear me? Just tell me in the chat section, guys. Good morning, everyone. Good morning. Yes, let me see. Are we live? Let me check this. All right. Good morning. Good morning, everyone. Good morning. Good morning, Ritu. Good morning. Yes. Good morning, everyone. Yes. Am I audible? Am I audible? Is my audio clear? Is my video clear? Just give me a thumbs up in the chat section if audio and video is clear. Good morning, Somesh. If the audio and video is clear, just give me a thumbs up in the chat section. Yes. Great, Nishta. Great, Somesh. Good morning, everyone. Good morning. Good morning. All right. All right. All right. All right. All right. So, I welcome you all again to India's largest education platform, that is your Unacademy. This is Let's Crack NEET UG English platform. All right. So, let me introduce myself. I am Nitesh Devnani and I have 5 years of teaching experience in chemistry, and I have taught over 2000 plus students who have got some great marks in your NEET examination. All right. Alright, so let me tell you about the subscription plan, guys. Just download this Unacademy learning app. Alright, just download this Unacademy learning app in order to access free classes also, as well as your this subscription plan also. Alright, so there are two types of subscription. First is your plus subscription. Alright, in the plus subscription you will have daily live classes. Alright, there would be live tests and quizzes. There are structured courses, as well as you'll have your unlimited access in your plus subscription. Alright, in the iconic subscription you will have all the benefits of your plus. All benefits of plus you will be getting, as well as you'll be having a personal coach. You will be having test analysis. There would be a study planner, alright, which you can revise it in your weekly basis. Alright, you'll have your study planner. Alright, now see, there are India's best educators, interactive live classes, structured courses and PDF, as well as your live test and quizzes. In the iconic subscription you'll have all this. You'll have all this, as well as you'll have your personal coach, study planner, experts guidelines and test analysis. Alright, see, for the iconic one, you are getting a personal coach as a personal mentor, so that is very beneficial if you are stuck in between, so that mentor or that expert can really help you. All right. Yes, so see, there are free classes also on our NEET UG platform. You just need to download an Academy learning app. All right, see, these are some of the educators on our platform. Now see, this is your NEET about the pricing. If you go for iconic subscription, 6-month course you'll be getting at 34,200 rupees. 12-month course you'll be getting at 58,500 rupees, and 24-month you'll be getting at 90,000 rupees. Whenever you purchase this code, just apply this code Nitesh YT. Nitesh YT, you need to apply this code in order to get 10% off, as well as you can avail all the benefits. All right. Yes, this is for the plus subscription. This is 1 month, 3 month, 6 month, 12 month, 24 month. All right, I would recommend you to go either for 12-month or 24-month course. 12-month course is for 34,650 rupees, and 24-month course you'll be getting it 50,400 rupees. Just again apply this code Nitesh YT. I will be benefited from it, and you will also get a lot of discount if you apply this code. All right. All right. Yes, so some of your doubt, Somesh. Alright, just apply the code Nitesh YT. Alright, you'll get your plan. Great. Good morning, Ilakya. Good morning, Amisha. Yes, NA. Yes, what is your doubt? Tell me. No, Keshav, I'll just have it. Yes. Yes, whenever there is a possibility of phenyl shift also, you can shift phenyl also. Wherever there is a possibility of alkyl, you can shift alkyl also. All right. Yes. Somesh, you're asking. Yes, see, there are different benefits for plus and iconic subscription. All right, for plus subscription, there are live lectures, there are live tests. In iconic subscription, you'll have your mentor also guiding you. All right, so that would be very beneficial also. All right, just apply this code Nitesh YT. All right, Nitesh is my name. You have been studying for long, and YT is my Nitesh YT. Complete is my code Nitesh YT. All right, great, great, great. I'll be soon coming. So Somesh, I'll be soon coming. Yes. Good morning, everyone. Good morning. Good morning, everyone. Let me see who all are present. Just give me a thumbs up in the chat section, guys. Who all are present? Just give me a thumbs up, guys. Just give me a thumbs up. Just give me a thumbs up, guys. Who all are present? Yes, NA. I'll take. Good morning, Nitesh. Good morning, Nishtha. Good morning, NA, Rahul, Somesh, Lakya. Good morning, everyone. Good morning. So this is our lecture 4 of your hydrocarbons in our previous class. All right, we have just started alkenes. We have just started alkenes in our previous class. Good morning, Keshav. Good morning, Kalai. Yes, we were studying alkenes. All right. Now we are going to start preparation of alkenes and properties of alkenes. Today we need to study preparation and properties of alkenes. All right. Good morning, Supriya. Good morning. Good morning. All right. So let us start our class. Let us start our class. Let us start with preparation of alkenes. All right. Let us start with preparation of alkenes. All right. So see, again there are 3 or 4 preparations we need to study each and every one in detail. All right. So see, your first preparation is from alkynes. From alkynes, just pay attention here. From alkynes. All right. First preparation is your from alkynes. So see, you have your this is your alkyne. All right. This is your, suppose this is R dash. All right. R and R dash are what both are alkyls. These are your alkynes. See, there is a triple bond and you pass hydrogen over it. You pass a hydrogen over it. Now the catalyst which you are using is palladium in presence of BaSO4 or palladium in presence of some carbon or in presence of some carbon. What happen is your hydrogen gets attached here at your pi bond. What is your answer? R C double bond R dash. Here it is H. Here it is H. So tell me whether it is cis or trans. I've told you about cis and trans. Tell me whether it is cis or trans. Tell me whether it is cis or trans. Yes, Somesh, we'll be studying from alcohol also. We'll be studying from every topic we'll be covering. Don't worry. Hello, Richu. Hello, Russell. Yes, we'll be surely having class. Yes, see, both the hydrogen on same side of your double bond. So this is having your cis. This is your cis. All right. So always remember, whenever you are using palladium and your BaSO4, this is palladium and BaSO4 is also known as your Lindlar's catalyst. This is also known as your Lindlar's catalyst. So with Lindlar's catalyst, always your cis product is formed. Always your cis product is formed. This is cis. Why? Because both the hydrogen are on the same side of your double bond. So this is what? Cis. All right. So from Lindlar's catalyst, your cis alkenes are formed. Are you getting my point? All right. Now suppose you have taken again this alkene and you are passing sodium in liquid ammonia. You are passing sodium in liquid ammonia. All right. Obviously there is what? Hydrogen. Obviously there is what? Hydrogen. And the catalyst which you are using are sodium in presence of liquid ammonia. Now what happens is your hydrogen is attached from different side of your double bond. One hydrogen is above your double bond, one hydrogen is below your double bond. Alright, so this, what is this? Is it cis or trans? Tell me in the chat section. Is it cis or trans? This is what? Transalkene. This is what? Transalkene. This is what? Transalkene. Alright. So this type of process where transalkene is formed, this is known as Birch reduction. This is known as Birch reduction. So you need to remember, when you are using Birch reduction, transalkene is formed. When you are using Lindlas catalyst, cisalkene is formed. Are you getting my point? Are you getting my point? Just like this video if you are able to understand everything. Yes. Now see, now do you remember preparation of alkenes which we have done in our previous lectures? Preparation of alkenes. See, I am just drawing a line here. Preparation of alkenes. See, R C triple bond C R dash, plus if you use hydrogen in presence of some nickel, platinum or palladium, what used to happen? What is your product? Tell me, what is your product? What is your product? Now in presence of nickel, platinum and palladium, alright, your product was these two molecules of hydrogen were used, and your product was this CH2 R dash, means your alkene was formed. Alkene was formed. Yes, alkene was formed. But just now we have seen R C triple bond C R dash plus H2 in presence of some your palladium and BaSO4, your Lindlas catalyst. Just now we have seen your product formed is what? Alkene. Your product form is what? Alkene. So what does this palladium and BaSO4 are doing? What does this palladium and BaSO4 are doing? Right, we need to understand this. So palladium and BaSO4 are acting as negative catalyst, they are stopping the reaction at alkene only. They are not further converted into alkenes. No, they are acting as negative catalyst. Alright, yes, this is a type of your controlled reduction. Alright, this is a type of your controlled reduction. Are you getting my point? Palladium and BaSO4 is acting as a negative catalyst. Alright, is this thing clear, guys? Give me a thumbs up if this is clear. Just give me a thumbs up if this thing is clear, guys. Alright, great, Amisha. Yes. Okay. Yes, great Alakia, great Rahul, fantastic. Are you getting my point? So always remember, from Birch reduction your transalkenes are formed, from Lindlas catalyst your cisalkenes are formed. Great Tamil, great Keshav, great Sonashri. Yes. Alright. Okay, shall we move forward? Yes. So this was basically from your alkynes. So there are two methods from alkynes, either from your Lindlas catalyst or from your Birch reduction. So there are two methods from alkynes. Great, Supriya, great. Yes. Now see, now second is your from alkyl halides. Alright. Now see, what is the procedure? Suppose this is your CH, this is your H, CH, and this is your halogen. X is your halogen. Alright. Don't get confused with the word X. You don't need to remember anyone with the word X. Alright. You might be having some history with your X, but this X here means what? This X here means what? Halogens. Alright. This X here means halogens. Halogens are fluorine, bromine, iodine. Alright. Yes, fantastic. So now this is your alkyl halide. This is your alkyl halide. Now you are passing some reagent. Now you are passing some reagent over it. Now you are passing some reagent. We will talk about what can be those reagents. All right. These reagents. What would these reagents do? See, what would these reagents do? This is your halogens. All right. Now this carbon is what? Your alpha carbon. This carbon is what? Your beta carbon. Wherever your halogen is attached, carbon next to it is your beta carbon. All right, that is your beta carbon. Now see, halogen is removed from here, hydrogen is removed from here, and a double bond is formed between these two. Hydrogen is removed from here, a halogen is removed from here, and a double bond is formed between these two. This is known as your preparation of alkenes from your alkyl halides. If you see, we'll cover. I'll tell you what can be the reagents. If you carefully observe, one hydrogen is removed. Yes. One halogen is removed. Yes. So this process is known as dehydrohalogenation. This process is known as dehydrohalogenation. Why? Because one hydrogen and one halogen is being removed. All right. What type of reactions are these? See, plus HX is formed, na? Plus HX is formed. What type of reactions are these? These are known as elimination reaction. Why? Because a small molecule such as HX, is being removed from it. So these are what? Elimination reactions. Now what type of elimination is it? It is beta elimination. Why? Now see, hydrogen and halogens are being removed from adjacent atoms. Hydrogen and halogens are being removed from adjacent atoms, no? Your hydrogen is here, your halogen is here. Both are removed from where? Adjacent atoms. So this is what? Beta elimination. Are you getting my point? Now what all reagents can be used? Which you can use? You can use alcoholic KOH. Alright, or you can use something like this: CH3O minus Na plus and CH3OH means an alcohol. CH3OH is an alcohol and CH3O minus Na plus is its salt. Alright, or you can use tertiary butoxide. Alright, or you can use this also. Alright, are you getting my point? Is this thing clear, guys? We'll be doing some questions, don't worry. See, what you need to do: one hydrogen is removed from here and an halogen is removed from here, simply, and just make a double bond between these two. Alright, is this thing clear? Sodium tertiary butoxide. I'll give you the formula also. Don't worry, we'll do some questions also. Is this thing clear, guys? Now see, let me give you some more examples of it. Suppose you have your this CH3 CH2 CH X, or suppose this is your chlorine and CH3, and your suppose alcoholic KOH is passed over it. Now we know that with the help of alcoholic KOH, what is the process? The process is dehydrohalogenation, correct? Is this thing clear? What we need to do, this alcoholic KOH is present, we need to do dehydrohalogenation, correct? Got it? Dehydrohalogenation we need to do. Okay. Yes, so this is your halogen. Tell me, what are beta carbons? How many beta carbons we have? How many beta carbons we have? How many beta carbons we have? Yes, see, this is your beta, this is your beta. Both are beta, na? Alright. Those carbon which are directly attached to this, which are direct, let's call this alpha. Alright, let's call this alpha. The carbon which is attached, which is having your halogen, we are calling it alpha. All the carbons which are directly attached to your alpha carbon are what? Beta. Are what? Beta. Yes, yes. Now see, now there are two options. Halogen will be removed from here. Now there are two options. You can remove hydrogen from here, or you can remove hydrogen from here. There are two options. Now suppose you have your this thing, this hydrogen H here, and this is your 2, and this is your hydrogen. So one time if you will remove hydrogen from here, suppose, so your product would be CH3 CH double bond CH CH3. Either this can be your product, or if you remove hydrogen from here, your product can be CH3 CH2 CH double bond CH2. All right, these two products are possible. These two products are possible. Yes. Now tell me which will be formed. Which will be formed? Only one can be formed. Which one can be formed? Which is more stable? Tell me. This is your one. This is your two. I've explained you in our previous classes stability of alkenes. Tell me which is more stable. Tell me which is more stable. Yes. Yes, this is your double bond. This carbon is your alpha. This carbon is your alpha. So it has 6 alpha hydrogen. This is your double bond. Only this is your alpha. This is your 2 alpha hydrogen. We have explained. I've explained you all this, in hyperconjugation, because it has more alpha hydrogen. It has more alpha hydrogen. All right. So this is more stable, and if this is more stable, this is your major product. This is your major product. All right. And this type of product which is more stable, we call them as ZZEF product. We call them as ZZEF product. And this is your minor product, means the product which is formed in less quantity, and this is your Hoffman product. All right, just the names. More stable one we are calling it as ZZEF, less stable we are calling it as Hoffman. Are you getting my point? Is this thing clear, guys? Is this thing clear, guys? Everything is clear? First one is more stable because it has 6 alpha hydrogen. Second one is less stable because it has 2 alpha hydrogen. More the alpha hydrogen, more is the stability of alkene. Is this thing clear? Give me a thumbs up, guys. Give me a thumbs up. Great, Tamil, yes. Great solo guy. So see, whenever there is a possibility, whenever there are two chances from where you can remove your hydrogen, you need to check that from where your stability of alkene is more. All right, this is your double bond. I've explained this is your double bond. All right, all those carbon which are attached to this double bond are alpha. This is your alpha, this is your alpha. So it has 3 carbon, sorry, it has 3 hydrogen, it has 3 hydrogens, total 6 hydrogen. And here this is your double bond. All right, and this is your alpha, this is your alpha. Okay, so there it has only 2 alpha hydrogen. All right, Alakia, just see our hyperconjugation lecture. Just check our hyperconjugation lecture, you will be able to understand everything. All right, great. Yes, yes, yes. Okay, 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 okay. Shall we move forward? Now see, now you know if these agents are present, alcoholic KOH or this agent is present, you are going to do your dehydrohallucination. Okay. Now there is one point. Always, like most of the time, your major product is what? ZZEF product. Your major product is what? ZZEF product. Most of the time. All right. Now let me give you one note. Let me give you one note. Suppose again, this is your again we are taking as same reactant. This is your reactant, and suppose we pass sodium tertiary butoxide, sodium tertiary butoxide, sodium tertiary butoxide. See, let me give you structure of this is your CH3 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 O minus Na plus. This is your reagent. This is your reagent. All right. Sodium tertiary butoxide. All right. Now again, I have just explained you that with sodium tertiary butoxide also, what type of reactions are going to occur? Dehydrohallucination. Dehydrohallucination. Now now again see, just pay attention here. Good morning, Babita. Good morning. Now this is your halogen. All right, now this is your hydrogen, this is your hydrogen. Again two products are formed. Again see, this is your alpha carbon, this is your beta, this is your beta. Halogen is removed from your alpha, hydrogen is removed from your beta, so your two products can be formed. Which one? CH3 CH double bond CH CH3, this plus, or you can also form this as your product, this as your product. All right, now see, this is what? ZZEF. I've just now explained you na in a previous slide. This is what? ZZEF. This is what? Hoffman. Now if you are using sodium tertiary butoxide, Hoffman product is major, Hoffman product is your major, ZZEF product is your minor. Why? Now we need to understand why. Hello Muhammad, hello Choryal, yes. Now we need to understand why Hoffman products are major when we are using sodium tertiary butoxide. Why? All right. So just pay attention here. Now see, this is a bulky group. This is a bulky group, na? Right? Alcoholic KOH was very small. Why this is bulky? Because 3,3 methyl or 3,3 alkyl groups are attached. This is what bulky group. So because of its bulkiness, you have your steric, there is a word known as steric hindrance. Now what does steric hindrance means? Steric hindrance means there is a lot of crowding. Steric hindrance, if I explain you in one word, this means crowding. This means crowding. So there is a lot of crowding, and crowding is due to what? This three big CH3 groups. Now due to this crowding, this inner hydrogen atom, see, there are two types of hydrogen atom here, this one and your this one. Due to this crowding, this hydrogen atom is not being able to extract. We are not able to extract this hydrogen atom. Why? Because there is a lot of crowding. So that's why this group, sodium tertiary butoxide, extracts this outer hydrogen. Extracts this outer hydrogen. It is preferring this outer hydrogen. Why? Because it is a very bulky group. It is a very bulky group. All right, so it cannot go inside and extract hydrogen. No, it is extracting hydrogen from outside only. And if outside hydrogen is being extracted, your product formed is what? Hoffman product. So that is your major product. Are you getting my point? So let me summarize this. If you have your alcoholic KOH or your this second reagent which I have written this, here your ZZEF product are formed. Here your ZZEF product are formed. But if you have your sodium tertiary butoxide, your Hoffman product are your major. Is this thing clear? Give me a thumbs up in the chat section. Give me a thumbs up in the chat section if this thing is clear to all of you. Give me a thumbs up in the chat section if this thing is clear. Yes, Chorial, we are having regular classes at 9:30 a.m. You can surely attend it. Everyone, please just give me a thumbs up if this thing is clear. Just this is a note, all right. We need to uh, keep in mind about sodium tertiary butoxide, all right. Great. Great. Yes. Fantastic. Now you guys only tell me. Suppose instead of this x, if we try to find order of reactivity, Now, if you have your fluorine, chlorine, bromine, iodine, which one would be most reactive? Your iodine would be most reactive. Alright, so reactivity order is fluorine, chlorine, bromine, and then your iodine. Why? Because the bond between this carbon and this halogen, weaker the bond, more is the reactivity. So iodine is the weakest among all in bond, so its reactivity is highest. Are you getting my point? If this thing is clear, just like this video, guys. Yes, just like this video if this thing is clear. Order of reactivity is clear. Iodides are the most reactive ones. Alright, see, there is a bond between your halogen and carbon and your halogen, na? There is a bond, na? Weaker this bond, more is your reactivity. Alright, so weakest bond is in your iodine. Because iodine is very big and carbon is very small. So the bond formed is not very good. So iodine bond is weakest, therefore highest reactivity. Now is it clear? Guys? All right. Yes. Great. All right. Okay. So this was your preparation from your alkyl halides. All right. There is a one more. There are a couple of more preparations. We need to see each and every preparation. All right. Next is your third preparation is your from vicinal dihalides. Suppose you have your this here H, here it is your halogen, here again C, this is your H, this is your H, again is your halogen. Alright, and we are passing zinc. In presence of some alcohol. Alcohol is your medium. Alcohol is acting as your medium for reaction. Now what happens is just pay attention here. Yes, your halogens from here are removed. All right, and a double bond is formed between these. So HCH double bond CH. This is formed. So alkene is formed. If you try to carefully observe this, this is what both the halogens are being removed. So this is what dehalogenation. Both halogens are removed, so this is what dehalogenation. Again, your X2 is formed. Is it elimination reaction? Tell me in the chat section. This is elimination reaction. Yes, because a small molecule is eliminated. X2. This is what? Elimination reaction. Again, this is what? Beta elimination. Why? Because this is your alpha, this is your beta. Both the halogens which are removed are from your adjacent atoms. So this is what? Beta elimination. All right, is this thing clear? Is this preparation of your alkene clear? This is very easy, you know. This is pretty easy. This one was pretty easy. All right, this one was pretty easy. Yes, is this thing clear? All right, great. Do you guys have any doubt up till now? Do you guys have any doubt up till now? Yes. Vicinal means adjacent. Vicinal, yes, Ritu. Vicinal means adjacent. See, these halogens are on adjacent atoms, no? Adjacent atoms. Yes, great. All right, great Nishta, great Ritu, great Supriya, Rahul, Ilakya, Amisha, Kalai, Choryal. Yes. Mahima, Keshav, Supriya, Tamil. Fantastic. Shall we move forward? No. Most of the time we are using zinc only. Most of the time we are using zinc only. Great, Kalai, great. All right. Let us move on to our next lecture. Next preparation is your from alcohols. All right. Now pay attention here. This is your very important. This is your important preparation. Suppose you have your alcohol HCH. Here it is your hydrogen, and you have your CH, and this is your OH. All right, this is your OH. Suppose you pass concentrated H2SO4 over it. All right. Now, when you pass concentrated H2SO4 over it, what happens is your hydrogen is removed from here, your OH is removed from here. All right, and a double bond is formed between this. Now, see, I'll tell you a mechanism of this. All right. Now, what is formed? Alkene is being formed. Correct. All right. Now, see, one hydrogen is removed, one OH is removed. So, one hydrogen, one OH. So, basically, you are removing what? H2O. Hydrogen and OH combine to form what? H2O, na? So, you are removing what? H2O. So, this is dehydration. This process is dehydration. H2O is being removed. Yes. Now again elimination. Again beta elimination. Why? Because hydrogen and OH are removed, or just call it as elimination. I'll tell you. Alright, H2O is being removed, na? So small molecule is being eliminated. We are calling it as your elimination reaction. Now let me give you mechanism of this reaction. This is important. We need to understand this in detail. All right. Yes. This is your mechanism. Let me give you mechanism. You need to understand this mechanism. All right. Are you getting my point? Just pay attention here. We'll take a complicated case. Just pay attention here. Suppose you have your CH3, CH2, CH2, CH2OH. Suppose this is your alcohol, and we need to pass concentrated H2SO4 over it. Now we need to know the product. Alright. So let me give you mechanism. In the first step, concentrated H2SO4 means your H plus. Concentrated H2SO4 is just what? It is just your acid. So it will give H plus, na? So this means CH3, CH2, CH2, CH2OH. And you have your H plus here from your concentrated H2SO4. Alright. Now here there are your lone pairs. Lone pairs are present. Yes. So this oxygen is having two lone pair, na? Oxygen has a 6 valence electron. 2 electrons are being participated in bonding. There are 4 electrons left, so there are 2 lone pairs. All right, yes. So this hydrogen attacks here on these lone pairs. Lone pair means negative charge, hydrogen is having positive charge, so this lone pair attacks here. So what happens is CH3 CH2 CH2, your CH2 OH H, this is your positive charge. Now oxygen is having what? Positive charge, because oxygen has donated its electron. Oxygen has donated its electron. Are you getting my point? All right. Now see, second step is, now oxygen is thinking, we have acquired positive charge, this is not good for us. This is not good for us. We don't need positive charge. All right. Now what happens is CH3 CH2 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 OH H, this is your positive charge. Now what happens is your oxygen takes these electrons with itself and gets removed as your water molecule. CH3 CH2 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 positive, and your water is being formed. Now just pay attention here. Just pay attention here. See, in our previous chapter GOC, we have studied reaction intermediates. What are reaction intermediates? Species which are formed during the reaction and which are consumed during the reaction. So this is your intermediate. This is your carbocation. Why? Because carbon is having positive charge. Carbon is having positive charge. So this is what? Simply your carbocation. Are you getting my point? Are you getting my point? And this particular reaction is known as your RDS. RDS is what? Pay attention here. RDS is your rate determining step. RDS is your rate determining step. Rate determining step means it is your slowest step. It is your slowest step. Are you getting my point? All right. See, RDS is your rate determining step. So there are multiple steps. There are 4-5 steps. Which one is the slowest step? This formation of your carbocation is your slowest step. Now, if this step is your slowest, this determines your rate, overall rate of the reaction. This determines your overall rate of the reaction. How fast or how slow a reaction can go depends on your slowest step. Now let me give you example. Suppose there are 10 students. And I am teaching to all the 10 students. All right. Now suppose, pay attention here. You'll get, there are, let me give you this. There are 10 students. All right. 9 students are fast and your 1 student is slow. All right. I am teaching a concept that these 9 students are able to understand in 1 minute. This slow student is able to understand this in 10 minutes. Now tell me, what is the overall time taken by me to teach a concept? 11 minutes, na? Because I have to take each and every one together. So 11 minutes are being total consumed. Why? Here it is 1 minute here it is 10 minutes. All right. Now suppose I want to increase my speed. Of teaching. All right. Suppose now I teach in such a way that you are able to understand in 30 seconds, these faster students, and this is able, and slow student is able to understand in 5 minutes. Now the overall minute would be taken as 5 minutes 30 seconds, correct? So see, the more impact is being created by your slow step, na? If this is halved, your rate becomes very fast. You can complete your reaction in a fast way. So your rate of a reaction also, similarly, your rate of a reaction also depends on your slowest step. All right. Now slowest step in this process is what? Formation of carbocation. Are you getting my point? Is this thing clear till now? Mechanism is left. I am completing it. Is this thing clear till now? Tell me in the chat section. All right. Mechanism is not completed. I'm again repeating. I am explaining it more. All right. I'm explaining it more. So RDS is what? RDS is your rate determining step. In this step, it is your formation of your carbocation. Formation of your carbocation. All right. Now see. Now your carbocation is being formed. This is your. This is your carbocation. This is your carbocation. What is the degree of this carbocation? What is the degree of this carbocation? This is your 1 degree. I have explained you in our previous classes that carbocation undergoes rearrangement. Yes, carbocation undergoes rearrangement. All right, so this 1 degree carbocation, can we rearrange it into such that its stability increases? Tell me in the chat section. Can we rearrange it? Can we rearrange it? Can we? Yes, yes, we can. We can. Just you can. This is your hydrogen. Just transfer this hydrogen here. 1 comma 3 hydride shift. I have explained this in our rearrangement lectures. All right. So what can be your answer? CS3 CH2 CH positive CH3. This process is known as rearrangement. All right. Now this is your 2 degree carbocation. Now tell me, further rearrangement is possible or not? Tell me, is further rearrangement possible? Tell me, further rearrangement possible or not? Yes, hello Richu, hello. No, further rearrangement is not possible in this case. Further rearrangement is not possible in this case. 2 degrees is your maximum. In this case we are talking. Now what happens is, I'll tell you trick, na? Don't worry. This is your mechanism. We need to understand mechanism. Then we will do it with trick only. All right. Now see. Now see. This is your hydrogen. This is your 2, and this is your hydrogen. Now we need to remove hydrogen. We need to remove hydrogen. There are 2 cases. Either remove this hydrogen or remove this hydrogen. All right. Either remove this hydrogen or remove this hydrogen. So see what all products can be formed. See, if I remove this first one, your product is this. Or if I remove this second one, your product is this. Now tell me which one is major. Now tell me which one is major. Now tell me which one is major. Which one is major? Sure, Richu. Yes. Which one is major? Yes. See, this is your alkene. This is your alpha. This is your alpha. So 6 alpha hydrogen. Here, this is your alkene. This is your alpha. 2 alpha hydrogen. This is your major. This is your minor. And major product, we are calling it as ZZF. We are calling it as ZZF alkene, and we are calling it as Hoffman alkene. Are you getting my point? Is this thing clear, guys? Is this thing clear? Great. Supriya, Choryal, Solo Guy, Kalai, Nishtha, Misha, Supriya. Fantastic. Fantastic. Great, Rahul. Yes. Great, Nishtha. Great, Amisha. Yes, yes. All right. So this was a pretty good process. This was a pretty good process. This is an important thing. All right. Now see. Now what all we have studied. What all we have studied. See. It is what? It is simply what? Just let me change this color. Let me take a different color. Okay, this one. This is what? This is a dehydration process. Alright, because of water molecule is removed. This is elimination reaction. Yes. Carbocation is formed. Yes. Whenever carbocation is formed, there is a possibility there is a possibility of rearrangement. There is a possibility of rearrangement whenever your carbocation is formed. Always you need to check about rearrangement. All right, so see, in the third process we have done some rearrangement. Then we have removed your hydrogen. Your ZF product are major. All right, let me give you one more example. Do you guys want to do one more example, guys? Let us do one more example. Okay, you need to attempt it. You need to attempt it. So see, let me just brief you which what I've explained you here. Suppose, see, this was your product. Sorry, this was your reactant, na? Let me just brief you. This was your reactant and you were passing concentrated H2SO4 over it. Simply do this thing. Simply do this thing. You can do this directly also. Simply do this thing. See. Simply do this thing. Just you need to form carbocation. Remove this OH and form carbocation. What is this? Carbocation formed. All right, all right. No issue, Chorial. Yes. Just simply form this carbocation. This is your carbocation. Carbocation is being formed. Now just simply, if rearrangement is possible, simply do rearrangement. Simply do rearrangement. We have done rearrangement. This is what? Rearrangement. Every time you don't need to write mechanism. Alright, just do directly. Rearrangement. This is formation of carbocation. Correct? Now you need to remove what? Hydrogen. Now you need to remove what? Hydrogen. So simply there are what? Two ways. Either this can be formed, or this can be formed. Alright, major is your this, ZF is your this, minor is your this. Minor is Hoffman, major is ZF. Are you getting my point? Is this process clear? Rearrangement are possible of any type. Rearrangement are possible of any type, Rahul. We just need to do rearrangement in order to increase the stability of carbocation. Alright, no issue. I'll be just explaining you. I'll be just giving you one more example. Okay, let me give you one more example. You guys need to attempt it. Then I will tell you. Wait. I'll tell you. Mm, Yes, this is your question. This is your question. Come on, everyone. Attempt it. First, make your carbocation and then proceed. Come on. Yes. Come on, everyone. Try this question. Just first make carbocation, then check for rearrangements, and then remove hydrogen. This is the procedure. Yes, come on, everyone. Attempt this. I'll be waiting for you, don't worry. See, these are important things, alright? These things take some time. Yes, what should be the answer? Shall I do it? Tell me in the chat section. Shall I do it? Shall I do it? Okay. We'll check. We'll check surely. Nishta, yes, we'll check. Yes, solo guy. Yes. I know where you guys are not able to do this. I know this. Just pay attention here. First, you need to make what? Carbocation. So simply make carbocation. Simply make carbocation. Simply make carbocation. This is what? 1 degree. This is what? 1 degree. Now just convert this 1 degree into what? Just you can do rearrangement, na? You can do rearrangement. Yes. In rearrangement, just pass this hydrogen here. What will, it will become? CH3, CH, CH3, CH, CH3. Here it is positive. Now this is what? 2 degree. Now you need to do rearrangement in such a way your stability increases. You need to do rearrangement of 2 times, 3 times, 4 times. You need to do it. Just increase stability. So see, there is one more rearrangement possible. You can convert this 2 degree into 3 degree. Yes, by passing this hydrogen. Alright, so yes, there are multiple rearrangements also possible. So CH3, CH3, this is your positive, this is your CH2, this is your CH3, this is your 3 degree. Now again check if rearrangement is possible. Again check if rearrangement is possible. Now it is not possible. This is your maximum rearrangement product. 3 degree. Alright, now what you need to do? This is your rearrangement product, na? This is your rearrangement product. Alright, now you need to remove what? Hydrogen. What are the possibilities? Tell me in the what are the possibilities? Just see. What are the possibilities, guys? Either remove hydrogen from here or here. Alright, see, because this carbon and this carbon are what? Same. Answer would come out to be same from these carbons. So see, your product can be, if I remove, this is your 1 and this is your 2, suppose. If I remove from 1, your answer is CH2 double bond C, CH3, CH2, CH3. Either you're this, or if I remove from 2, your answer is CH3, C double bond C, HCH3. Either you're this. Now tell me, this is your 1, this is your 2. This is your 1, this is your 2. Tell me which is your major product. Tell me which is your major product. Tell me which is your major product. For major product, you need to see alpha hydrogen. This is your double bond. This is your alpha. This is your alpha 3, 2, 5 alpha hydrogen. This is your double bond. This is your alpha. This is your alpha. This is your alpha 3, 3, 3, 9 alpha hydrogen. So this is your major. This is your minor. For major we call it as Sedze. For minor we call it as Hoffman. Is this thing, guys, clear to all of you? Is it easy now? See, things might feel difficult in starting, but if you practice questions, you will be very much comfortable. Is this thing clear now? Is this thing clear? One more question. Are you ready for one more question, guys? Are you ready for one more question? Are you ready for one more question? All right. All right. One more question is, now we are introducing some cyclic structures here. All right. This is your question. Do it. Come on, everyone. Alright, after this class, just to see our lecture of for your rearrangement of carbocation. Just see my lecture of rearrangement of carbocation. Alright, you will be very much benefited from it. Lot of questions we have practiced there. Come on, everyone, try this question. Try this question, guys. Also, like this video if you are able to understand everything. I hope you guys have already liked it, but if not, then do like this video, guys. Yes. Yes. What should be the answer? What should be the answer? If you guys have any doubt, you can surely post it in the chat section. I'll reply. Yes. Give me the IUPAC name of it. Give me the IUPAC name of it. What is your answer? Yes, guys. Your answer in the chat section. Just first make carbocation. Alright, then see for its rearrangement, and then remove hydrogen. This is the complete procedure. Alright. Yes. First form carbocation. Alright, let me do it. First we are forming carbocation. So if we are forming carbocation, we this is your carbocation formed, OH is being removed, and this is your carbocation. What is the degree of carbocation? Degree of carbocation is 1 degree. Here it is 1 degree. Now we need to make rearrangement. So see here there are hydrogen present, so you can do rearrangement in such a way such that this is your form. Alright, see this is your bit complex one. Just understand this, guys. See, now this is your 2 degree, this is your 2 degree, correct? Now you need to expand your ring. Now you need to expand your ring. Yes, you need to expand your ring. Simply do 1 2 3 4 5 6. I've explained you expansion of ring in our rearrangement classes. You can see this. Pay attention here. Just try to recall it. What we used to do, this 2 3 bonds goes over 3 and 3 attacks your 1. Now see what is formed. 1 is connected with the 3 is C, 3 is connected with 4, 4 is connected with 5, 5 is connected with 6, right, and 6 is connected with 2. 6 is connected with 2. Alright, and 2 is connected with 1. Alright, and 1 is having this group also, CH3 group. This is your CH3 group. And 2 would be having positive charge. Is this thing clear? Is this ring expansion clear? I've explained this, right? I've explained this. Now again tell me, is rearrangement possible? Tell me in the chat section, is rearrangement possible now? You need to look carefully. You need to look carefully. Is rearrangement possible now? Is rearrangement possible? Yes, very good, very good, very good. It is possible. See, 2 is having positive charge. Suppose, now what is the degree of 2? This is 2 degree. Now suppose if 1 would have your positive charge, then it would become 3 degree. So yes, rearrangement is further possible. Your rearrangement is further possible. So this is your final rearrangement. Yes, very good, very good, very good. Alright, now this is your 3 degree. This is your 3 degree. Now you need to do what? You need to extract hydrogen. You need to extract hydrogen. Please pay attention here. I'll again explain you. See, this is your hydrogen. So this is your beta. This is your beta. This is your beta. So see, this and this beta are what? Same. So what all products can be formed? What all products can be formed? Your one product will be, if you extract from here, your one product would be like this. Another product would be like this. Alright, so tell me which one is major, 1 or 2. This is your 1, suppose this is your 2. Which one is major, 1 or 2? Tell me which one is major, 1 or 2? Tell me. Just check for alpha hydrogens. For alkene stability, you need to check alpha hydrogen. So see, this is your alpha, this is your double bond, na? This is your double bond. See, this is your alpha, this is your alpha, this is your alpha. Here 2, here 2, here 3. So 7 alpha hydrogen. Are you getting my point? And here this is your alpha, this is your alpha. So here 4 alpha hydrogen. So yes, this is your major, this is your minor. Is this question clear, guys? Degree of carbon. Alright, I'll explain it. I'll again explain this particular whole question. Is this, first of all, tell me who all are able to understand this? Who all are able to understand this question? Just give me a thumbs up in the chat section. Okay, I will explain ring expansion. I will explain ring expansion also. I will explain degree of carbon also. Alright, just pay attention here. See, degree of carbon, we are deciding on the basis of this. See, this. Now what is the degree of this carbon? Means, I'm explaining expansion, don't worry. See, this is your carbon. Alright, this carbon is attached only with one carbon, na? So this is what? 1 degree. So this is, and it is having positive charge, so 1 degree carbocation. Now see this. What is the degree of this? Means with how many carbon it is directly attached? With how many carbon it is directly attached? 2 carbon. So this is 2 degree. Alright, and see this. With how many carbon it is directly attached? This carbon, middle carbon. With how many carbon it is directly attached? 3. So it is 3 degree. Rahul, is this thing clear, guys? Are you able to identify now degree of carbon? That's why GOC, I was again and again telling you, our first chapter, GOC, that's why it was very important. Your complete organic chemistry is based on your GOC, believe me. Alright, complete organic chemistry is based on GOC. Your resonance, your lot of hyperconjugation, inductive, your carbocation, carbon ion. You need to see these lectures. Just type my name on YouTube, you'll find lectures. Just watch those lectures. All right. Yes. Okay. Now you were telling me about your ring expansion. See, ring expansion is, see, ring stability. First you need to understand about ring stability. All right. See, there are three membered ring, there are four membered, five membered, six membered. Your six membered ring is your most stable, then four, five, then four, then three. I've covered this rearrangement lecture separately in our videos. You can check it. I'm briefing you about this. All right. Now see, this is your ring stability. So whenever there is a five membered ring, it would try to convert into six membered. Why? It would increase its stability. Whenever there is a four membered ring, it would try to convert into five membered ring. Why? To increase its stability. All right. Now see, this is your carbocation. Expansion of rings always only happens with your carbocation. This is your carbocation. This is a four membered ring. This is a four membered ring. Correct? Just simply number this. I'm explaining it to you with the trick. Simply number it. 1, 2, 3, 4, 5. Alright. Always just do this. 2, 3 bond comes over 3 and 3 attacks 1. So what is happening? Just pay attention. 1 and 3 are being attached. 1 and 3 are being attached. This 3 is connected with 4. 3 is connected with 4. This 4 is connected with this 5. Yes. 4 is connected with this 5. This 5 is connected with this 2. Yes. This 5 is connected with this 2. This 2 is connected with this 1. 2 is connected with this 1. Yes. And see, 2, 3 bond comes over 3. Means 3 was acquiring negative charge. So 2 will acquire what? Positive charge. 2 will have positive charge. Alright. So this was about your ring expansion. Let me give you one more example. Alright. Alright. You attempt this question now. Start numbering it 1, 2, 3, 4, 5 and then do it. Start numbering it 1, 2, 3, 4, 5. Start numbering in 1, 2, 3, 4, 9. No, Kali. Always identify degree with carbon. See, if carbon is 1 degree and positive charge, 1 degree carbocation. If carbon is 2 degree, positive charge, carbocation, 2 degree carbocation. Simply. All right. Yes. Simply write 1, 2, 3, 4, 5, 6 and then proceed. This is the trick. Now why I am telling you trick? You need to apply this trick, okay? You guys like this video if you are able to understand everything. This is your 1, 2, 3, 4, 5, 6. Alright. 2, 3 bonds come over 3. 3 attacks 1. So 1 and 3 are being attached. Yes. 3 is attached with what? 4. 4. 4 is attached with what? 5. 5. 5 is attached with what? 6. So here it is 6. 6 is attached with what? 2. So there it is 2. And 2 is attached with what? 1. 1. And positive charge would be on what? 2. No, Tamil. How benzene is formed? No, this is not benzene. Benzene is something else. Benzene has pi bond, 3 pi bonds. Yes, cyclic hexene, yeah. Carbocation, but carbocation is formed. Alright. Is this thing clear now? Only funda for your rearrangement is to increase the stability. This was 5 membered. This was 6 membered. So you have just increased stability by converting 5 membered into 6 membered. Russell, you just need to check this. I have again told you there 1, 2, 3 trick only. I've explained this in our video. No, 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 not further. In this case, not further. Any rearrangement is possible. Yes, all right. Now see this question. Now see this question. This was your question. This was your question. See, first was your 1 degree formed. Just pay attention here. Russell, pay attention here. Yes, I'll explain you. I'll explain you. Yes, Ritu, I'll explain you. Wait. This is your 1 degree carbocation. Alright. Now it rearranges into 2 degree carbocation. Yes. Now see, rearrangement is possible only when this is your ring and your next carbon, this carbon is having positive charge. Alright. So this is your rearrangement. Then only rearrangement is possible. So this carbon was having positive charge. So we rearranged to form, this was our 5 membered and we converted into 6 membered. Alright. See here also on 2 only we are having positive charge. Correct. But now you need to check every time. Now can I increase the stability of carbocation? Can I increase the stability of carbocation? You need to always ask yourself. So this was your 2 degree. Then we thought, yes, we can increase the stability. We can do it 3 degree by doing this. Alright. Now simply remove hydrogen. Now simply remove hydrogen. Ritu, that is basically trick. Alright. If you are removing, this is your 2, this is your 3. If you are removing the bond between 2 and 3 and there are electrons, na? You are passing this electron on 3. So 3 is having what? Negative charge, which is attacking our carbocation. So 2 will have what? Positive charge, na? Yes, Russell. Watch the resonance video. It is available. GOC, GOC in our GOC resonance video. Now is this question clear? Now is this question clear, guys? Now is this question clear? Give me a thumbs up, like this video. Is it difficult? Is it difficult? Now I hope it must be easy. Guys, just type my name, Nitesh Devnani, rearrangement of carbocation. Just type my name, Nitesh Devnani, rearrangement of carbocation. You'll get rearrangement video. There, just after this class only, just check rearrangement. This is very important. This was your only first reaction of rearrangement. Let me tell you, there are lot of these reactions in which rearrangement is there. All right, you need to check this rearrangement thing, otherwise your organic chemistry would be very tough. Yes, that's why I was again and again repeating, your GOC is important. GOC is important. You need to understand GOC first. Great, Saba, great. At 9:30 a.m. we are having regular classes. 9:30 a.m. we are having regular class. Try to attempt and try to come on time. Yes, mechanism. You don't need to always do mechanism. Alright, you need to know what are the steps. Carbocation, rearrangement, then alkene. These are your steps. Alright, this is your step. Is it clear, guys? Do you guys have any doubt? Ask me in the chat section. Ask me anything. I'm just waiting for you. Do you guys have any doubt? Do you guys have any doubt, guys? Any general doubt you can ask me. Any general doubt you can ask me. Like this video if you are able to understand everything. Yes. See, Ilakya, everyone just need to understand this. We are studying very precisely. All right. We don't need to study. See, I know you guys are having lot of material. You guys have seen lot of material where there are different types of reaction being taught, different things are being taught. They are of no use. Let me tell you today, they are of no use. All right. We are studying specifically for your NEET examination. We want to cover only those mechanism which is very specific for your NEET. All right. Okay, Lakia. Yes. Yes. uh Ritu, vinyl and allyl are your groups. Vinyl and allyl are your groups. Yes, I'll surely try. Um, NA, I'll surely try for real. Acha, okay. Tell me in the chat section how many of you want a special class. Special class would be on your Unacademy platform. How many of you want a special class for rearrangement? Just give me a thumbs up. In a couple of days, I can arrange it. In a couple of days, I can surely arrange it. Yes, Nishta, in Wood's reaction, if you carry out with different alkyl halides, your mixed products are formed. Your 3-4 products are formed. Just check our Wood's reaction product chapter only. We have covered mixed reactions also. Okay. Okay. You guys need rearrangement. Okay. I'll try. I will try. And okay, just follow me, Nitesh Devnani. Just follow me on Unacademy. All right. And follow our channel, Telegram channel. Just follow our Telegram channel. Telegram channel is NEET. Let's crack. Let's crack NEET UG English. This as our channel. Just follow our channel on Telegram. I'll post my class there. See, there are groups allyl. This is your vinyl group. This is your vinyl group, and this is your allyl group. These are different groups. This is your allyl. Yes, Ansab, I'll be taking rearrangement. Yes, surely I'll be taking it. Yes, I'll be surely taking it. Don't worry. Just follow this our Telegram channel. All right. I'll be sending links of all my classes here only. Any other doubt? Like this video, guys. At 9:30 a.m. we have our regular classes. 9:30 a.m. we have our regular classes. Just attend these classes. We are targeting 170 plus chemistry in your NEET. We are targeting 170 plus chemistry. So you just need to attempt these lectures at 9:30 a.m. Okay. Just follow this channel and sub. I can't tell you the correct timing right now, but I will surely tell in this Telegram channel. Okay. Yes. All right. Okay. So I will see you tomorrow morning 9:30 a.m. sharp. I will see you all. All right. Okay, bye bye, take care. Just like this video, guys. Bye bye, everyone. Take care, guys. Take care, guys. Bye bye. Have a great day and start practicing questions. Start practicing questions. Bye bye. Bye bye. Bye bye.